Good afternoon to all. I have a very complex topic for BSc third year student. The subject is your solid state physics and electronics, and this topic is quite complex for students. So I decided to make its video lecture for revision at your home. Along with the classroom teaching, this is just a help for you so that this concept is going for simple for you. Right. Okay. So the topic is atomic structure factor. Basically, why this topic is in concern of the day, because when we go through the XRD analysis of any material, then we know that we generally use copper K alpha as X-ray beam from at your esteemed institution. Their XRD machines are there, so they use this wavelength 1.54 angstrom. When the material is exposed to X-ray beam, then we got a spectra, and after analyzing that spectra, we are able to find the few structure parameters of your material. Okay, what the basic physics involved there, how we get the spectra, the main reason for this is scattering. In the first phase of this article, we just want to find atomic scattering factor when we deal only with the whole atom and its one electron. So dear students, Bragg's or Lewis equations that we have already studied in previous classes, those equations 2d sine theta equal to L lambda for direct lattice, 2k dot g minus g square, this is for reciprocal lattice case, and Lewis equations are 2ab sine theta cos alpha equal to n lambda, 2b sine theta cos beta equal to L lambda, and 2c sine theta cos gamma equal to L lambda. These are Lewis equations. So Bragg's consider that there is a reflection by the planes inside the material at atomic level, but Lewis give his idea about the scattering at atomic level, whether the scattering is from the whole atom or from the electron inside the atom. If we have two types of scattering involved in the total scattering of an atom, that is from the whole atom and from the one electron, so there will be a constant, the constant that is atomic scattering factor F. So if we go through this article, what we find that the intensity of scattering from actual crystal, which are composed of atoms arranged on a crystal, then we must take into account the fact that scattering is actually done by the clouds of electrons which surrounds the nucleus. So even along with the scattering from the atom or the electron, we have also, there is a very the quantity of scattering is very less, the scattering by the nucleus, and we can neglect the scattering from the nucleus. So amplitude of radiation scattered from the atom is only f times that from a single electron. हम इसको कैसे समझेंगे? I have expression. Yes, You can note it. What is that? What is atomic scattering factor? Atomic scattering factor describes the scattering power of the single atom in relation to the scattering power of single electron. And mathematically, F equal to amplitude of radiation scattered from atom to the amplitude of radiation scattered from an electron. So this is the basic formula we are using to find the expression for it. So how we can get this expression? I have uh, a file that is on my board, XP pen. So what I am asking that, if consider this is the atom, this is our atom, and let the electron inside the atom is at this place, let it is at the center, this is the electron. Okay, so if the electron is scattering, there is a scattering from the electrons from for the the scattering is in a spherical symmetric way like this. So what can I do? I have to understand that if consider this is the scattering center, this is the center, this is the whole scattering space is there. I consider the electron is at the center of the scattering, and I consider electron here, and the situation is like this. I consider the electron is here at this place. What I do, I consider a small volume element of this scattering sphere like this, and this volume is at distance r, and the normal I am taking, I consider this is the normal to the scattering plane, and the angle that r makes with n, that I consider phi. I consider this is the small element, volume element dV. So yes, this is the electron sphere. Obviously, the charge on this surface will be rho dV like this. This is the surface charge on this volume element. So the X-ray beams that incident on this surface, and after that gets scattered, I consider the N1 cap, that is the direction for this X-ray, and from let there is another X-ray from the beam that striking the electron like this, and again I take same N1 cap is the direction, and this scatter direction that I consider by N2 cap. This N2 represent the scattered rays and N1 represent the incident beam. Like this. This is the scenario we have basically. So obviously the beam that is scattered from this point and from this point, there will be a phase difference phi. I consider phi r be the phase difference between the 2 points, and according to the definition of the this is 2 pi by lambda, and this is r vector dot n cap, and this expression I have already discussed in Loeys equation concept. Okay, so after that what we have, let's go for PPT presentations. So yes, here I am writing that to calculate F, consider an atom containing electrons arranged in a spherical symmetric configuration around its center, which is taken as origin. Okay, let R be the, this is R be the radius of the atom considering a small volume element dV at R. Let rho r be the charge density at this point, and the charge enclosed by the volume element is rho dV. N1 and N2 represents the direction of incident and scattered X-ray beam respectively. Okay, so this is the figure that I make on the board, and this is the statements you have to write in your notebook. Okay, so here the wave scattered from the electron and the volume element dV is given by. ठीक है. We have to first of all find the phase difference. दोनों के बीच में phase difference क्या है? Phi r equal to 2 pi by lambda r dot n. Okay. This is from your, we know that del phi, आपने optics में ही पढ़ा है ये, 2 pi by lambda into the path difference delta x. We use that expression here. So this expression from this point, and here when n is, where n is normal to the scattered plane. Okay, this is about the n. What is n? And after doing that, this is our expression for phase difference. This is Rn, phi with the angle between R and n, 2 pi by lambda Rn cos of phi. And also we find that n equal to 2 sin theta. We have also knowledge about this from the Lois equations. Lois equation we have find it n equal to 2 sin of theta. So putting the values here, n की value हमने यहाँ डाल दी. So what I have, I have the 4 pi by lambda sin theta and r cos of theta. I consider mu that equal to 4 pi by lambda and sin theta is another constant. This is we take a constant here. So we are able to find the phase difference between the incident and scattered beam, X-ray beams or scattered rays. So in the next step, we have to find the amplitude of scattered wave, amplitude of wave scattered from the located at origin के पास. Yes, यहाँ से कितनी scattered हो रही है, यहाँ से कितनी scattered हो रही है, we can represent that by this. ठीक है, x is the distance of this scattered wave. Okay, and amplitude of wave scattered from small volume and dB is given by this expression. And yes, the both scattered wave phi r with the phase difference, that is we represent that by phi r with the phase difference here, phase difference. Okay, now using the definition, if we use the definition of f, the amplitude scattered by the volume element to the amplitude of radiation scattered by the electron. So this is the ratio that reflect your scattering factor for this volume dB. Okay, so according to spherical polar coordinate system, we have dB equal to this r square dr sin phi d phi d theta. So putting this value in our, yes, okay, we can cancel a by a, then iota kx, these are cancel out, but we have left with this here. So we have exponential iota phi r rho r square dr sin phi d phi and d theta. On solving it, we have f equal to, this is for r, this is for phi, this is for theta. So on solving this, what I have, r square dr exponential iota phi r sin phi, this is come to 2 pi. So now it is 2 pi r square. These are some variable related to r in this range, and I have exponential iota mu r cos phi sin phi d phi for this integrand. And this integrand is standard one, having value like this. It is like 2 sin theta divided by theta, like this. So on doing this, on putting this value, f equal to 0 to infinite 2 pi r square dr rho r 2 sin mu r by mu r, like this. And finally 2 into 2, that is 4 pi r square rho r sin mu r by mu r dr. This is the required expression for your atomic scattering factor. So atomic scattering factor is always less than z. Z is what? Z is the number of electrons or protons inside the number of electrons in the atom. So kindly note it. So this is the required expression. If you have any query, we can discuss in the class. When you come to the class, when you attend my class, we will discuss all the problem related to this. Kindly note it. So thank you very much.